will see Now we'll see the reactions in the hydrocarbon or organic chemistry, some of the reactions in the organic chemistry. And we'll start with the easiest one, which you probably have seen, which is combustion. So combustion, even in the chemistry 20 and science 10, you have seen that is in two types, is a complete combustion reaction and a incomplete combustion reaction. When we have a complete combustion reaction, what does it mean is that the oxygen gas is excess. So you'll have plenty of oxygen gas. The general reaction for the combustion will be something like this: CnHm plus O2, and those are in gas form, will form a carbon dioxide gas and water vapor gas. This is a highly exothermic reaction. A huge energy is released as this. Complete combustion reaction has always excess of the unlimited sources, unlimited quote-unquote sources of the oxygen. One reaction, an example, which you probably have seen, is a methane gas, which is the gas that we use in our home to heat. Will form a carbon dioxide and hydrogen gas. Okay, what do you see and what do you notice as the complete reaction is when you see a blue flame in your heater. So if you go to your heater at your home, you will see that there is a blue flame that is at the heater, which is a very good or indication that you'll have a complete combustion reaction. On the other hand, or as the second type of combustion reaction, is that is incomplete combustion reaction, and still is between a hydrocarbon compound and the oxygen. But what do you see is that the oxygen is limited. Okay, so in the case when you have methane gas that is reacting with a limited amount of oxygen, then what is happening, and this is the general one, every time is like this, it's a carbon monoxide gas that is produced and water gas. The indication that it is an incomplete combustion reaction is that what do you notice here is a yellow flame. Just for your information, the carbon monoxide is a very dangerous gas because it doesn't smell, it doesn't feel any, it doesn't have any color or anything, and it's very dangerous. And when you breathe it if it is in the air and you breathe it and you see that it is in your blood, what it goes, it has the tendency to become carbon dioxide. So you grab one oxygen from your molecule of blood, and then therefore the risk of dying from the monocarbon or carbon monoxide is very high. Therefore, make sure that in your home you have that carbon monoxide signal that it's showing if there is a carbon monoxide in the air of your home. Okay, so this is for the first type of reaction is the combustion reaction, which can be on two types, and always the products are carbon dioxide and water, and carbon monoxide and water. Now we'll move to addition. So addition reaction, it is happening on with alkane and alkene, alkane and alkynes. So alkene and alkyne. Why is it like this? Remember what we said? Those are double bonded. They have one or more carbon with double bond, and this is one or more with triple bond. Okay, so now it cannot happen with alkanes, because in order to have an addition, what it is happening is that you break the bond, and then this bond is forming, is added to other things, to other, those bonds broken, if you are adding something else. If you break a single bond, then the carbon chain will be broken. Therefore, in order to have addition reaction, you should have either a double bond or a triple bond. So this is happening only when you have multiple bonds that one of them is broken, allowing the free bonding across the multiple bonds. Always on an addition reaction, what you will have is you will have two that are reacting together, reactants, and only one product, because you are adding it. Okay, you are adding whatever into the one of the reactants. We'll see an example. So let's say that you have, let's clear first this, what is happening. So let's suppose that we have ethane. Ethane is with a double bond, and then you have a hydrogen here, on each, two hydrogens in each of the carbons of the ethane. If we express this in with as a Lewis dot diagram, then we will have something like this: carbon, carbon, like this, and then we will have one hydrogen here, one hydrogen here, one hydrogen here, one hydrogen here. And now what is happening? This bond here is broken. So one of them is broken. And now what do you see is that, let's see, let's do it here. What do you see is that carbon now is becoming like a tetrahedral. So you will have hydrogen like this, and hydrogen like this, and here and here. And you will have two electrons that are here. So what do we have to do? We have to fill those two electrons with two atoms to complete the bond between the two. And this is why this is what it is adding. So you start with two reactants plus something else here. You start with two reactants, but then you end up with only one. Okay, so let's see an example of propane that is reacting with bromine. So propane will be something like this: C, double bond C, and then hydrogen is here. This is what you will see. Okay. Hydrogen, hydrogen, and then let's say that is reacting with bromine. Bromine is Br2, which means that you'll have one Br, two Br. Okay, so now this bond is broken here. Okay, and then what do you see? Again, you'll have, I will do it in a different color. So you will have the hydrogen that is going up, because it's becoming tetrahedral shape, and then you'll have one hydrogen here and one bond here that you need to complete. So then on where you are breaking the bond, you have to add the bromine. So then what you will see will be something like carbon, 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 and then you will have one hydrogen. This is what it was, and then the bond that is broken here, it's going here, so you will have Br and Br. So you will add where the double bond is broken. Let's see another one again. Propane, that it is reacting with water. So C, 1, 2, 3. Okay. And water, but what water is HOH. So HOH. So then again, this double bond here is broken. It cannot happen when we have, if it is broken in a single bond, then addition cannot happen. Then the hydrogens becomes tetrahedral. So then you will have CHH, CH, CHH. So all of them will be H's. And then the bond that is broken will be here. One will be H, one will be OH. And you do know what this is, which is an alcohol. Okay, so now let's see another, and again, let's emphasize the fact that we have only one product. So we start with two reactant 1 and reactant 2 in every case, and then you have only one product. The same procedure is happening when we have an alkyne. So let's suppose that we have, let's see, and then 3, 3, 4, 4. Okay, and let's say that is reacting with bromine, Br. It can be hydrogen, it can be fluorine, it can be anything. Okay, then I will stop here, and then you stop and see if you are on the same track as me. So the logic is that one of those triple bonds is broken, and then what do you see is that you will have a carbon, carbon, carbon with one hydrogen, and here you will have double bond, and you will have, sorry, nothing here. This bond here will be something that we have to add, and then it goes into carbon, another bond here that you need to add something since it is broken, and then carbon, hydrogen, hydrogen, hydrogen. So now what you are adding here is a bromine and a bromine, a halide. Or if you have a triple bond as well, again, and now you are making it react with HF. So I will take the same thing as for simplicity, and then 2, 3, 2, 3, 4, 1, 2, 3. Okay, so it's reacting with a HF. Then one of those bonds is broken. Therefore, what do you see is that we'll have C, 1, 2, 3, C1. I will make it in a different color so that you can see. And then double bond C, another bond here that we need to fill it with something, and then we have carbon, carbon with hydrogen. So now in one of those, what we can add, since HF is the same as saying H and F, like this. So one is F here and H is here. Okay, so again, even as you see it in this case, you will notice that it is only one product. But let's take a look now as to an addition reaction when it's kind of the same thing, but now instead of one molecule of, let's say, Cl2, we have two molecules of Cl2. So when we start with that, will be 1, 2, 3, C, C, and then 1, 2, 3, 1, 2, 3. And now we have, as this is the first product or reactant, and now we have two molecules of CO2. So if the possibility to break more than one bond in other multiple bonds is based on the second reactant, then this is what will happen. So not only one bond, but two bonds will break down, and then what we will have will be all four carbons connected between each other into single bonds. Okay, and then we'll have HH. Oh, no, I will not do this with this color. So HHH, and then now those two of the three double bonds are broken down. So we'll have 1, 2, 3, 4, and those will be filled with Cl, 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 and Cl because we have two Cl. But we still have only one product in the addition reaction. Okay, so now how do we see that an addition reaction is happening? We see that an addition reaction is happening when we do those diagnostic tests. Diagnostic tests. There are two types of tests that we do. The first diagnostic test is a reaction with bromine. The reaction with bromine. So what do we notice is that bromine is, when it is added into a hydrocarbon, bromine itself has a brown color. Brown color. And if the reaction is happening, then it is turned into a colorless. So if we have, let's say, ethane that is reacting CHHHH with bromine, then what we see is that we have one of the double bonds is broken, and then we will have bromine here and here where the bonds are broken. Okay, and the indication that this reaction is happening, it turns from brown yellow kind of color into colorless. You see, if you have a hydrocarbon and you add bromine on it, then you will notice that it is, as soon as it is added into ethene, then will be broken down into, or will change the color into colorless. The second diagnostic test that we use is the reaction. So the second diagnostic test is the reaction with KMNO4. So when you don't need to know the reaction as to what is it happening, but what do you need to know is that KMNO4, if the addition reaction is happening, it changes the color from purple to brown, and you see the precipitate. So if you are asked, or if you are, if it is indicated into the question of the diagnostic test with KMNO4 is performed to indicate if there is a reaction happening or not, then and the purple stay purple, then no addition reaction is happening. But if purple color is changing into brown color, then this is an indication that addition reaction is happening. This is in terms of the combustion and addition, and we will do substitution and elimination, and then call it a day.